Okay, so we are going to continue to solve systems through elimination when we're not giving opposites. So like if you look at this system, you'll see that the x's are not opposites and that the y's are not opposites. So you have to get opposites. You either need opposite x's or opposite y's. So remember, that's when you need to do the least common multiple. So here's my x values, here's my y values, and I'm going to go ahead and find their multiples. So 6, and then 12, and then 18, and then 24. Stop and check my -4. So -4, -8, -12. All right, I'm going to stop because what did I find? I found opposites. Okay, if I multiply 6 times 2, I get 12. And if I multiply -4 times 3, I get -12. So now I have opposites here. But go ahead and check your y values and see what you think. So you've got 3, 6, 9, 12, 15, 18, 21, 7, 14, 21. Okay, so now I have that. Need one of them to be negative, so I can multiply this by -7 to get -21. And then I can multiply this by 3 to get +21. Now, I think working with lower numbers is easier, and you see how I multiplied the 6 times 2 and this -4 times 3. Those are smaller numbers than here, okay? -7 is pretty big, and I have to multiply a lot of things by it. So I'm going to choose to stick with this and make my x values opposites. All right, so I'm going to make my x values opposites. But again, you can't just change the x. You have to change the whole thing. So since I multiplied the 6 times 2 to get that 12, I have to multiply this whole equation by 2. So everything in the equation by 2. And then since I multiplied this -4 times 3 to get the -12, because I was looking for those opposites, I multiplied by that 3. I have to multiply everything in this equation by 3, not just the -4. Okay? So go ahead and do that. So 2 times 6x is 12x. And then 2 times 3y is 6y. And then 2 times 27 is 54. And now go ahead to your other equation. 3 times -4x is -12x. That was the whole reason we did it. 3 times 7y is +21y. And then 3 times 27 is 81. And again, now that we have opposites, by just changing each of these equations, we can go ahead and add and eliminate. So I'm going to add 12 plus -12 cancels out. That was the whole reason we did this. 6 plus 21 is 27y. 54 plus 81 is 135. Now let's solve. Divide by 27 on both sides so that we find out that y equals 5. Okay, so we have the y value. So our ordered pair is an x and a y. So we already have the y. Of course, we're missing this x. So how do we find it? We replace y with 5. And let's go ahead and use the first equation. But remember what I told you in the last video. Don't ever use your new equations, because what if you messed up? Okay, so always go back to the original. So I'm going to use this original first equation, and I'm going to replace the y with 5. Okay, so instead of 6x plus 3y, I'm going to do 6x plus 3 times 5 equals 27. So 6x plus 3 times 5 equals 27. And then I've got to multiply this. This is +15. So 6x plus 15 equals 27. Solve your two-step equation. So add a -15. So we get 6x equals 12. Then divide by 6. And x equals 2. So you think you know your whole solution now, 2, 5. That's the point where the two lines cross. But you know you want to always check. So in order to check it, I'm going to replace x with 2 and y with 5, but I'm going to use the other equation. I used this to find x. Now I'm going to use this one to check it. Okay, so instead of -4x, I'm going to do -4 times 2. And instead of +7y, I'm going to do +7 times 5, and then equals 27. Okay, so let's write that out. -4 times 2 plus 7 times 5 equals 27. All right, -4 times 2 is -8. 7 times 5 is +35. negative 8 plus 35 is 27. 27 equals 27. So you know your solution is correct. You checked it and you're good to go.